what do I have? 15 minutes to make a presentation with 100 transparencies? Okay, let's try that. I'll be speaking about the observations on a couple of seismically isolated structures, hospitals, because it appears to be that the only isolated structures in the particular region where the earthquake of the 6th of February hit were hospitals, and there were approximately 12 or 13 rather seismically isolated structures. In our mission, we're able to actually visit only 2. This wasn't a specific mission for seismically isolated structures, it was a general mission. It included quite a bit of geotechnical engineers in the team. I guess you saw the presentation, and then of course when structural engineers and geotechnical engineers are in the same bus for a few hours, things get out of hand. So we end up looking only at the 2 seismically isolated structures. Sorry, guys. I'm gonna be showing a few pictures of our observations in the facility in a hospital at the southern part of the region hit at Dortiol. It's the Dortiol Government Hospital, and the other one is the Nazib Fazil City Hospital, which is in Kahraman Maras area, close to the city, and that was a facility which was under construction. I don't have time to show anything about the rest, which I've gathered from the literature. So let's continue and see. Here you see in blue the 2 hospitals that I'll be talking about, and what you see in yellow are right next to each one of those seismically isolated facilities, the locations of the accelerometers. So we had records for those, for very close. For some of those isolated hospitals, the records that we had from the particular earthquake, not only the Pazardzhik, but also the Kinozu or Elbistan earthquake. So we are able to get an idea of what the kind of motion these facilities experienced under those earthquakes, the response that is of the seismically isolated structures. And at the end of the presentation, I will present a scenario if these seismically isolated hospitals, and here are some of the details of those hospitals, were located in the area of the Antakya, which experienced most of these strong motions that that shown us previously the other members of the team. And it's interesting to look at the scenario at the end. So the 2 facilities that we visited had approximately 350 isolation bearings each one. Different capacities. The under construction hospital in Kahraman Maras had plus minus 1 meter displacement capacity, and the Dortiol had much less capacity, was approximately 40 centimeters. Now let's see at the Dortiol facility. This is a general picture, and the station actually that was close to this facility was the station with a code number 3134, approximately a distance of 0.9 kilometers, a kilometer away. And these are the pictures from the facility when we visited. You can see the main entrance, the moat cover or the seismic gap cover between the building, between the hospital and the surrounding soil. This is as we walk around the facility, where we follow basically all the cover and the moat that surrounded this structure, and you can see different views of that. So from what you see and from what we saw, it didn't appear that there was much movement or much response, if you like, from these 2 events of the 6th of February. And this is actually the isolation level is 2 floors below the ground level. And you can see here on the, You can see here on the left, the moat wall, the seismic gap, approximately 50 to 60 centimeters. And here it is a kind of a later built kind of a wall. I'm not sure if that was a masonry wall or that basically closed or prevented the entrance to the moat. Now, of course, if that had happened before the seismic event, this wall would have broken. This is the picture that we took when we visited. It appears to be that this particular barrier has been built after the earthquake hit and the facility moved, because it did move, but it moved not much, and we will see later on. Here is a couple of pictures from the seismic isolation level. Remember, there was 2 floors below the ground. A closer picture of the isolators. The isolators used in this particular facility were, as in most of the facilities in this particular region, were built in Turkey by the TIS. This is a company that builds mainly pendulum type of isolators, friction-based pendulum type of isolators. These were a double pendulum isolator system that was used for this facility. And here is the distance between the facility, the hospital, the seismically isolated structure on the right, and the location of the record. Unfortunately, I wasn't able to get my hands on from the AFAD's website the details of the record in order to do some work here locally, but I found from some colleagues that they published recently, some Chinese colleagues that they published recently a paper. I found this particular graph which supposedly shows the records of that particular station from that particular earthquake, and it appears that the oops, I don't see why I cannot see. Sorry. I'm trying to, okay, here we are. What we can see from here is that the displacement spectra, that is the response of this particular seismically isolated structure, which I assume that it was that has an isolation period of the order of 3 seconds. Remember, 2 seconds is a lower side, 4 seconds is a higher side, so on the average is approximately 2.5 to 3.5 seconds is the isolation period range of those structures. For 5% damping from the spectra, it was expected from this type of motion approximately 1 kilometer away from the location of the structure to be approximately 30 centimeters displacement. However, of course, this was for 5% damping. If we consider 15 to 20% damping, that reduces to approximately 10 centimeters, 8 to 10 centimeters maximum displacement. Now, what we were able to see, oops. Okay, and here we are with the 2 pictures from different locations around in the surrounding of the hospital, and on the left there is the moat cover and some debris that have entered the small gap that has been created most probably by the motion and maybe the permanent displacement experienced by this particular small type of motion, this particular seismically isolated structure. On the right, you can see a picture, and if I'm not mistaken, this particular shoe is Pavlos boot, and you can see here what I show as a permanent displacement of the order of 3 to 4 centimeters, and the maximum displacement, if I can consider that, if I can take that from the picture, to be of the order of 10 to 13 centimeters. So the if I believe the response spectra that I took from the literature, more or less something like that happened in this particular seismically isolated structure, and that much was the response of it for the from those two earthquakes. Now, if we look to the second facility that we visited, the one in the Karhaman Maras, this was a facility which was under construction, and you can see that the condition of part of this under construction seismically isolated building on the left. On the right, you can see the foundation boat or foundation area of this facility from a picture that was taken, of course, before the construction or during when the construction started. Right next to this seismically isolated structure was another part of the hospital which was not seismically isolated. It was a conventionally built reinforced concrete frame structure with minor damage, very minor damage. It performed rather well. Now, going to the next picture, and as you can see, part of this wing of this facility, a hospital facility, which was seismically isolated, was had the superstructure, the reinforced concrete frame superstructure on it, and the part of it was in the process of basically putting the superstructure on top of the seismic isolators. Again, the seismically isolators were double curved pendulum bearings with the manufacturer being the same company as previously. It's a Turkish manufacturer, and the capacity, remember, the capacity of those bearings are of the order, the displacement capacity, that is of the order of plus minus 1 meter. Closer pictures to the seismic gap, to the moat and the opening. Now, remember, this was under construction. The seismic bearings, the isolators, were locked, and we're going to see a picture afterwards. And until the end of the construction, as supposed to be, and then they are unlocked. They can give into service after the end of the construction. However, what happened here is the following: as you can see down here, the lock was broken. Of course, the motion was rather strong in this particular area. It was very close to the fault line, and what we were able to observe was a permanent displacement of the order of 3 to 5 centimeters, depending on the location of the bearing, if it was in the corner or in the middle. And you can see some pictures on the right as the bearing, one of those bearings looked it looked inside. Again here, the closest station, acceleration recording station, was approximately 5 kilometers away. That was with a code number 4625. And here is the response spectra, acceleration and displacement response spectra. 5% again response spectra for the two east and north directions, motion directions. And of course, with this particular seismic motion, even though it's 5 kilometers away, if we assume that it was the same that hit the particular the hospital, then it for 5% again damping, we would have expected approximately 50% displacement. However, this was friction bearings with the damping equivalent viscous damping of the order of 15 to 20%. So the maximum displacement that was expected from such a system would have been of the order of 20 to 25 centimeters. Of course, we didn't have any way of knowing what exactly was the maximum displacement experienced by the isolation system on this structure. The only thing we could observe was the permanent displacement. And remember, all of these bearings were locked, and then they had the lock to be broken, or the locks to be broken before they moved. Now, Now I'm going to the scenario that I promised you before. The scenario calls for a seismically isolated hospital in Antakya, and in Antakya on the left and in Skedderun on the right, there were two of the hospitals that suffered. One collapsed, the other one suffered quite a bit of a structural damage. These were conventional built. The one on the right, of course, was a structure which was initially built in 1950s, 68, 50, somewhere there. And maybe the reason the collapse must have been that one. Again, remind you that the scenario calls to take any of those seismically isolated hospitals and been lifted and placed in Antakya at the particular locations of two records, the 3123 and the 3124. This is from the locations of those accelerometers in downtown Antakya. And here are the response spectra, the 5% response spectra shown also before. And you can see the really strong motions, or in both north direction, north south and east west. And on the right, you can see the response, the 5% again damping, the displacement spectra, which is the response of the isolation system, again, for 3 seconds, let's say, it goes of the order of 1.5 meters. Of course, none of those designs of the hospitals would have actually survived these particular motions. If they had 5% damping, again, they would have jumped over outside of the bearings. But now let's be a little bit more practical and assume that they had approximately 15 to 20% damping because of the friction. That is the range of damping that is this type of designs show, and of course in those cases we expect displacement response of the order of 0.7, approximately 70 centimeters for this particular motion. And I concentrated on this particular motion. I won't show the stuff, the analysis for the 3124. Now, look at these. These are the acceleration time history on the right and displacement time history on the left, sorry, and the displacement time history on the right for the actual ground acceleration in orange, and for the actual acceleration response of the base isolated structure with the with 3 seconds isolation period and 20% damping, equivalent viscous damping, that is. And here are the spectra. The spectra of the green spectra showed how the superstructure, that is the structural frame above the isolation level, would have responded, and the orange is the ground, is the spectrum of the ground acceleration. And of course, it's expected that we have a big big peaks at around 3 seconds. This is the isolation period that we talked about. However, for this particular green spectra, what we are interested at is the what I have shown here as a blue, with a blue shade, which are the range of the superstructure dynamic period or periods in terms of the accelerations that these superstructure which will experience of the order of 0.4 or 0.5 G, if you like. Again, not very low, and the displacement of the order of approximately 10 to 15 centimeters. This is the superstructure. This is the isolation system, and closing, and I hope that I kept the 15 minutes that I had in my disposal. And this is the closing, and saying quickly that the structures, the seismically isolated hospitals structures perform as expected were used. with a couple of exceptions where the isolation system would have worked fine if the engineers or the maintenance crew of the hospital, of a particular hospital, hadn't filled the moat, the seismic gap with gravel. Things happen, you know, sometimes. Now, looking at the scenario and this simplified, if you like, analysis and easy to understand shows most probably that the seismically isolated structures would have performed well in Antakya if they had used, and if, of course, the isolation system was designed with a capacity of the order of 1 meter, as the case in Karhaman Maras. And that ends this presentation. Thank you for this opportunity.